Hey everyone. So, we hear it all the time, right? AI can learn, it can reason. Some people even say it can think. But what is actually going on in there? When an AI makes a decision, what's happening inside that black box? Well, today we're going to pry it open and take a look.
So let's just cut through all the hype and the mystery for a second. Forget about the sci-fi stuff you see in movies. In the next few minutes, we're going to get right down to the nuts and bolts. And you're going to see that what AI is doing is somehow both way simpler and way more mind-boggling than you probably think.
You know, if you want to understand any complex system, you've got to start with the smallest piece. And for an AI's neural network, that's the neuron. And honestly, you might be shocked at just how simple this little building block really is. That's it. Seriously, it is not a tiny little brain. It's not sitting there wondering about the meaning of life. A single artificial neuron is basically just a tiny specialized calculator. Its whole job is to take in a few numbers, do some super simple math, and then pass one number out the other side. Okay, so what is this super simple math? Let's do it. We're going to put one of these neurons under a microscope and watch exactly what it does, step by step. This is the moment where all the magic kind of vanishes, and you see the raw mechanics.
So to make this really hit home, let's use a real-world example. Imagine we have a single neuron, and its job is to predict how well a student is going to do, their success score, based on just a few bits of info. All right, look at this. On the left, you've got the raw data coming in. The student studied for 2 hours, slept for 3 hours, and finished one assignment. But the really interesting part is on the right, the weights. Think of weights as little volume knobs for importance. The neuron has learned, somehow, that studying is a big deal, so it turns that knob up to 0.5. Sleep is pretty important, so that's at 0.3. And assignments, less important, so that knob is turned way down to 0.2.
So, what does the neuron do with these numbers and these knobs? The very first thing, the foundational act of so-called AI thought, is just dead simple multiplication. It takes each piece of data and multiplies it by how important it is. That's it.
First up, hours studied. It takes the 2 hours, multiplies it by that high importance weight of 0.5, and gets 1.0. Simple.
Next, it looks at sleep. 3 hours times its weight of 0.3 gives us 0.9.
And finally, that one assignment with its little weight of 0.2 gives us 0.2. See? Just basic math.
Okay, so after it's done all that multiplying, the neuron's next step is even easier. It just takes those 3 results and adds them all together.
So we take the 1.0 from study, add the 0.9 from sleeping, add the 0.2 from the assignment, and it all adds up to 2.1. That number, 2.1, is the neuron's final output. Its combined assessment of the situation. And this, right here, this is the big reveal. This is the key thing to understand. When we say a neuron is thinking, this is what it's doing. It's not magic, it's not consciousness, it's just multiplying and adding to figure out how important different things are.
So you're probably thinking, okay, if one neuron is just a dumb calculator, how in the world does AI do all the amazing stuff it does? Well, the secret isn't in one neuron. It's about what happens when you connect millions of them together. The power is in the network. So let's zoom out. These simple little neurons get organized into layers. First, you have the input layer, which basically just takes in the raw data, like our students' hours. Then you have the hidden layers, and there can be a lot of them, which is where all those calculations we just saw happen over and over again. And finally, you have the output layer, which spits out the final answer.
Now here's where your brain might start to melt a little bit. It's not a neat little line of connections. In a typical network, every single neuron in one layer is connected to every single neuron in the next layer. And every one of those lines, every connection, has its own unique little volume knob, its own weight.
Just try to picture the scale of this. Let's say you have 2 pretty small layers with just 100 neurons each. Well, that's 100 times 100 connections, which is 10,000 connections. 10,000 individual volume knobs that the network needs to get just right. And of course, the big models today have millions, even billions of these things.
Okay, so you've got this insane web of connections with thousands of volume knobs, but how does it get smart? How does it figure out which knobs to turn up and which to turn down? And that brings us to the final and most important piece of the puzzle, how it learns.
This quote really just says it all perfectly. When we say an AI learns, we don't mean it's gaining wisdom. It's not a conscious thing. It is literally just the process of automatically tweaking all of those specific numbers, all those little weights.
So here's the bottom line. Learning is just a giant automated feedback loop. The network makes a guess, it checks to see if the guess was right, and if it was wrong, it makes a tiny adjustment to all those little volume knobs, hoping that the next guess will be just a little bit closer to the right answer.
And the process itself is almost beautiful in its simplicity. 1, the network makes a guess about the student's score. 2, it looks at the real answer to see how wrong it was. 3, if it was wrong, a clever bit of math goes backward and nudges all 10,000 of those weights just a tiny bit in the right direction. And 4, it does this again, and again, and again, millions and millions of times until the knobs are tuned just right.
And that's really the whole secret. There is no ghost in the machine here. What we call AI intelligence is just what emerges from an incredibly simple calculation, multiply and add, happening across a huge network, being refined through millions of tiny corrections, all at a speed that is almost impossible for us to comprehend.
Which, of course, leaves us with one last kind of wild question to think about. We just pulled back the curtain on the machine and seen that its version of thinking is built on a foundation of dead simple math, just scaled up to an absurd degree. So, what does that imply about the billions of neurons firing away inside our own heads? It's definitely something to chew on. Thanks for watching.